Okay, we're going to start using half angle formulas. This is actually 5.5b, not c, like it says. Alright, formulas. Using a half angle is a little bit different. You have to figure out what angle to put over 2 to make it work. See if I can circle that better. Okay, you have to figure out what angle you're putting over 2 to get the same answer. So when I rewrite sine of 105, I'm going to rewrite it as sine of something over 2. And the only way I can do that, let's see, what would that... That would be 210. Okay, if you'll notice on your unit circle, 105 is not a friendly angle, but 210 degrees is. Okay, so this 210 is my u that I'm going to be plugging in here. So plus or minus square root 1 minus cosine of 210. Notice I'm only putting in the top number, not the over 2, divided by 2. And now I'm answering the question, what is the cosine of 210? So plus or minus square root 1 minus cosine of 210. Okay, that lands in quadrant 3. Reference angle, we're going to be at a reference of 30 degrees. Cosine is going to be my adjacent side. So my adjacent side is going to be across from 60. Makes it radical 3 over 2, negative. So plus radical 3 over 2, all over 2. And we need to get fractions out of fractions. We can't have complex fractions. So what we're going to do is get common denominators across the top. So now we've got plus or minus the square root of 2 over 2 plus radical 3 over 2, all over 2, plus or minus square root 2 plus radical 3 over 2, still divided by 2. Now we can multiply by the reciprocal, and now I'm going to have plus or minus the square root 2 plus radical 3 over 4. I can take the square root of 4, so simplify it just a little bit further. Plus or minus, radical still across the top, over 2. And then I have to decide, am I positive or am I negative? So I look at my original problem. It says sine of 105. I'm in quadrant 2, or I'm in quadrant 3. In quadrant 3, sine is negative. So final answer, negative radical 2 plus radical 3 all over 2. And I said that wrong. We need to look at our original problem, which I didn't. We're looking at 105. 105 lands in quadrant 2, which is positive. So my mistake, it should be a positive. Try a very similar one, cosine 105. You're going to use 210 again, but use the cosine formula. Okay, here we are. Plugged in the formula, only plugged in 210. Cosine of 210 is negative radical 3 over 2, which turns it to a minus. So 2 minus radical 3 over 2, all over 2. Multiply by the reciprocal. Radical 2 minus radical 3 over 2. Plus or minus, we need to be determining this. Cosine of 105. 105 is in quadrant 2, where cosine is negative. So we can, it won't let me erase, but we only need the negative here. Okay, we're going to practice solving. We're going to end up having to use our identities. First thing we need to do is substitute in the identity. So I'm going to have 1 plus cosine squared x equals 2. And instead of cosine squared x over 2, I'm going to plug in the identity for cosine squared x over 2, or cosine x over 2, and then I'm going to square it. So this is going to be plus or minus the square root of 1 plus cosine x over 2 squared. What does a square do to a radical? Cancels it out. Also, my 2's are going to fall out. So my radical's going to fall out, plus or minus is gone, 2's are gone. Now I have 1 plus cosine squared x equals 1 plus cosine x. Everything equal to 0, cosine squared x minus cosine x equals 0. Factor out a cosine x. Cosine x minus 1 equals 0. Solve both equations. Where's cosine equal to 0? That's my x-coordinate is 0 at pi over 2 and 3 pi over 2. Cosine x equal to 1, where's my x-coordinate 1? That only happens at 0. So pay attention to your interval. We didn't need k's, just the 3 answers. All right, very similar. Try it, come back and check. Okay, so we put in the identity, squared it, takes care of the radical and the plus or minus. Sent them over 2, I'm going to multiply my 2 over. 2 cosine squared x equals 1 minus cosine x. Everything over to the left side to get it equal to 0. 2 cosine squared x plus cosine x minus 1 equals 0. Factoring, set my factors equal to 0, and solve.